paving projects can involve spreading thousands of tons of mix across a large area over multiple days. Variations in mix composition, weather conditions during placement, and procedural practices can cause differences in pavement properties. While some sections meet specifications, such as asphalt fill density, and others, like asphalt laboratory air voids, may not, FAA specifications evaluate pavement acceptance using the percent within limits, which statistically estimates the percentage of pavement meeting the specified criteria.
Engineers use PWL to determine how much of a lot meets specification limits. This approach is more precise than older methods, which focused only on an average quality and overlooked consistency. Years of data show that pavement properties typically follow a bell curve. The center of the curve represents a mean value, which is the same as the average. This is the only statistic used in older acceptance methods.
Typically, when measuring a pavement property, the result will be close to the average. However, some values will be further from the average, with some deviating enough to fall outside the required specifications. The distance from the mean is determined by the consistency of the property, which is usually measured using a statistic called standard deviation.
High consistency means most of the values are close to the average, resulting in a low standard deviation and a narrow bell curve. Low consistency, on the other hand, is indicated by a high standard deviation and a wider bell curve. The proportion of pavement failing to meet requirements depends on both the property's average value and its consistency. Lower consistency means a larger portion of the pavement will fall outside of the limits. An average value closer to the limit also increases the likelihood of values exceeding the limits. Therefore, calculating PWL for a pavement property requires understanding both its average value and the consistency.
The general process for calculating PWL involves taking samples, determining the mean value, standard deviation, and quality index, and then looking up the PWL using the quality index. While the calculations may seem complex, FAA specifications offer detailed, step-by-step instructions to guide the process.
Here's an example of how to calculate PWL for mat density. FAA provides guidelines for calculating PWL based on 3 to 10 samples. Specifications usually divide lots into sublots, requiring one mat core sample for each sublot to determine density. Select one randomly located core from each sublot. In this case, we're going to call it Lot A, with sublots 1 through 4. Determine the density of each sample, A1 through A4. Calculate the average for the lot by adding the sample densities together and dividing by the number of samples, in this case, 4.
Next, calculate the standard deviation for the lot. Although it may seem complex, the process mainly involves basic arithmetic. Subtract the average value from each sample. Square each result. Add up all the squared values. Then divide by the total number by 1 less than the number of samples. Finally, take the square root of this number to find the standard deviation. In our example, the standard deviation is 1.15. For convenience, many calculators and computer programs like Microsoft Excel have built-in functions to compute averages and standard deviations automatically.
The next step is to calculate the quality index, a statistical measure that evaluates how closely the samples align with the upper and lower specification limits. The limits establish acceptable quality ranges and serve as thresholds that pavement must meet or exceed. Certain properties, like rut resistance, have an upper limit, meaning samples tested for rutting must fall below the upper quality index limit, while density requires samples to be above a lower limit.
Use the average, standard deviation, specification limits, and these equations to calculate the upper and lower quality indices.
To complete the PWL density example, subtract the lower specification limit of 96.3 from the average, and then divide by the standard deviation. This gives you a quality index of 1.4348. The final step is to locate the PWL in Table 1 of the specification item C110, method of estimating percentage of material within specification limits. Identify the column corresponding to the number of core samples collected. Next, locate the smallest number in the column that exceeds the quality index. In this case, 1.4400 is the smallest number in the column for N4 that is greater than 1.4348. Follow the row to the left column to find the PWL. The PWL, for our example, is 98.
Some properties, like air voids, have both upper and lower limits. Calculate the PWL for each limit separately using the same air void samples. To find the total PWL, add the upper and lower PWLs and subtract 100. This total influences the pay factor.
Contractor payment is tied to the percentage of work meeting quality standards. For example, if 98% meets standard, contractors may earn credits. However, low PWLs, indicating excessive work outside of the limits, can result in deductions. This system encourages contractors to uphold or exceed quality standards.
Ultimately, PWL helps maintain pavement performance and integrity, benefiting agencies, contractors, and the communities they serve.